Hello, I'm Frederick, lead software engineer at Nordson EFD, and we're going to be talking about how to use the Nordson NX client application to familiarize yourself with the NX protocol. The guide on connecting your NX controller to your network is in a separate guide. This video will show you how to use the NX protocol. So we're going to start with assuming that your NX controller and your computer are already on the same network so that they communicate with each other. To access the NX client application, you can download it from the PCP-DIN-NX website. Once it's downloaded, there's no need to install it, but you do need to extract it to a folder of your choice. From then on, you can open the client application from that folder or add a shortcut. Once it's open, you'll see a screen that looks like this. For DIN-NX controllers, you'll want to change the controller unit to PCP on the dropdown. Now you'll be able to see that the register names in the input table and the output table are for the PCP. To connect to your unit, you'll need to type in the IP address of your unit. In my case, that's 192.168.10.51. You can leave the port as 9000, and then you can click the Connect button. It will pop up with a message that's saying it's either successful or has failed. In this case, our connection was successful. Now that we're connected, we can test our connection by using the Receive All Values button underneath the output table. And you can see that we've received values in our output table. These are the current values that are on the controller. For the message log, here on the left side, we have the message log, which is helpful for understanding the NX protocol, which is used for communicating with the controller. It logs both what is sent to the controller as client and what we received back from the controller as server. In this example, we sent 3, 0, 20, semicolon. The 3 means that it was a request for information. The 0 means that we are requesting that register 0 be the start of the values that are sent. And the 20 means that we want 20 values. So we're effectively requesting all the values from register 0 through 19. The response starts with repeating what we sent, so the 3, 0, 20, followed by all of the values. So you can see here that 4 matches with register 0, digital's 4, and 2 is the program num, and so on. If we want to change a setting, say the RPM, we can set the new value next to RPM. Here I'm setting it to 70, and then we can send that value by clicking the Send R2 button. In the message log, you can see that we sent 16, which corresponds to the write command. And then the second number is still the first register that we are referring to. And the third number is still the number of registers that we're dealing with. So in this case, we're sending register 2 and just one register. And the value that we send is 70. You can also see that the server repeats back the command. In the case of an error, it will instead repeat an error message. So if I type in 10,000, for example, and try to send that as register 2, we will instead see that the server responds with an error code. This same method can be used to send all of the settings, including the digitals register. Most of the settings just correspond to a single number. However, the digitals register contains multiple functionalities. The way we combine multiple functionalities into a single number is by using the binary representation of that number, and each functionality corresponds to one bit. So, for example, the functionality to load a program from memory is a single bit. In the case of program 1, that's bit 6. In binary, the 6th bit corresponds to 2 to the 6th, which is 64. So if we would like to load program 1, I can type a 64 for register 0 and send that. This loads all of the values for program 1 into memory. If I then receive these values, it will change all of the parameters to match what's loaded into what was loaded into program 0. We can also save these values, and to save values into a program, we need to use 2 bits. The bit that you use to load, i.e. the 64 in the case of program 1, as well as the save program bit, which is bit 1, which corresponds in binary to 2, because 2 to the 1th is 2. So to specify both bits, we add them together, and we get 66 as our value. So if I send 66, that will save the current values into program 1. Some other functions of the digital register include the e-stop, the trigger, a purge trigger, and the analog select bit, which allows you to control the RPM via an analog signal. Some of the other features that are available in the client application are the ability to send or receive multiple registers without receiving or sending all of the registers. So here you could specify exactly what your base register is, where you start, and the number of registers. So if I would like to just know the pump size and the dispense volume, I could start with register 5. Oh, that's send. So if you'd like to receive both the pump size and the dispense volume, I can enter a base register number of 5 and the number of registers of 2 and click the receive multiple. Then here in the client log, you can see that we requested, which is a 3, we started with register 5, and we requested 2 registers. The final additional feature is the ability to poll for receiving. So if you would like to continuously refresh the output table, you can poll at any interval you would like. So if you just specify a polling time of 2 seconds and click Start Polling, then every 2 seconds we will receive all the values. That concludes the demonstration of the NX client application. Thank you for your time, and please reach out to us with any questions.